All right, in this video, we're going to go ahead and be doing some difference of squares and perfect square trinomial review because it has to do with some patterns that we learned in Math 2, and they are applicable to what we're doing right now, okay? And so, first pattern that we're going to go ahead and take a look at is, again, the difference of squares. And just to show how the difference of squares works, okay, is that basically when you have something that is in this form, something squared minus something squared, it can go ahead and be factored into this form, okay? So why does that work? Let's just go ahead and take the right-hand side, for example, and go, let me get out of this marker here, okay? And that is going to give me a minus b times a plus b. And so to show that this equals that right there, we multiply it out and we get a squared, and then we're going to get plus ab, and then we got a negative b times a. That's going to give us a negative ab minus b squared, and you can see that these go out and we are left with a squared minus b squared, which is a cool little factoring pattern. Okay, so our trick is to go ahead and get two things squared, they were subtracting two things squared rather, and then apply the pattern. So let's go ahead and start with this guy right here, and then we'll just go ahead and work our way kind of like that. So anyhow, to show that we got two things that are squared, okay, we think about that 64 and we think, well, how can we go ahead and write 64 as a perfect square? And so we may have guessed that it might be 8 times 8, or 8 squared. So therefore, I'm going to go ahead and use that factoring pattern, and I'm going to say that x minus 8 and x plus 8, okay? And to show more specifically why that is going to go ahead and work is that, again, I'll just do it for this one, is that if we do a squared minus b squared equals a minus b, a plus b, okay? So you can see that in this right here that x and a line up, okay? So all these a's turned into x's, and then all these b's, the b and the 8 lined up, so all these b's turned into 8's, okay? And that's how we go ahead and use that factoring pattern out. And so once we get that, we know that we're done factoring those two, okay? And sometimes the difference of squares needs to be set up a little bit. So for example, with this guy right here, I know that as it stands, it wouldn't be a difference of 2 squares. However, I notice that I can factor a 2 out of there, like so, okay? So now I'm like, okay, 2 times x squared minus 9 squared. Well, I can rewrite that as 2, and I'm going to go x squared minus 3 squared, because I can rewrite the 9, right, as 3 times 3. And then I can apply the difference of squares to this guy right here. So at the end of the day, that's going to give me 2, and then I'm going to have x minus, I don't need that bracket there, I'll leave that out. So 2x minus 3 and 2x plus 3, like that. And now we used the difference of 2 squares in a different way, all right? And sometimes we're going to have some coefficients in here where I look at this next one, which is right here, and I say, okay, how can I rewrite 4x squared as a perfect square? Now obviously the y squared is a perfect square, but I can go ahead and rewrite that as 2x times 2x, which would give me 4x squared minus y squared. And now I have exactly what I want, okay? 2 square things being subtracted. So this is going to give me 2x minus y and 2x plus y, okay? Using that pattern out. Now, sometimes we have to get really creative, and in this one, this is something more of a challenge problem than anything. But as long as you can rewrite things as perfect squares, you can go ahead and keep doing it out. So let's see how this problem unfolds. Now, x to the fourth, we can be clever and we can rewrite that as x to the second, because we would multiply those two, right? And that would give us x to the fourth. So I'm going to do that. I'm going to go x to the second power, and I can rewrite 81 as 9 times 9. And so therefore, I can say, all right, well, that's going to be x squared minus 9, x squared plus 9. Now, we have another perfect square right here. So we can do that again. And as we saw earlier, we know what up here, that x minus 9 is going to go ahead and break down into, so I'm just going to show all the steps here, is that we would have x squared minus 3 squared, and this guy has a plus sign, so we can't do anything with it. It has to be a difference. And so we would go x minus 3, x plus 3, and then x squared plus 9, and now we have it all the way factored out. Okay, so that's just a quick overview and review of the difference of squares. And I also want to take a look at these perfect square trinomials here. Okay, and the perfect square trinomials is basically we don't go in this direction too often. We go in this direction a lot. So usually it's more like for an expansion. Okay, and to show why that works is that we'd have a. Notice that we have a plus b to the second power. Now, a lot of students like to go ahead and put that into each one. It doesn't work like that. You can't do that, okay? What you need to do is that you need to set it up a plus b times a plus b, and now we need to FOIL it out. And so that would give us a squared. We'd have a times b, and b squared. And so you notice in the center here, we can collect those two. We have two ABs, right? And so that's going to give us a squared plus 2ab plus b squared. And that's where we get this guy. So let's go ahead and expand those out, okay? So what I'll do is that I will do the first one out kind of in slow motion here. And what I'm going to do is that I'm going to do this, right? And that is going to copy the left-hand side of this equation right here. And I'm going to let a equal 2x, and I'm going to let b equal 3. And why is that? It's just pretty much simply because they match up right here. Okay? And so from here, I wrote b equals b. Oops, that is not what I wanted. So one moment, let me fix that up. All right, now we're in business. And so what I'm going to do then is that since I'm going to copy down the right-hand side and say x squared plus 2ab plus b squared, and basically throw in into each part, for every a, that's going to turn into a 2x, and for every for every b, that's going to turn into a 3, and then I'm going to multiply it out. So let me do that. I'm going to go parentheses are important, 2x squared plus 2 times 2x times 3 plus 3 squared. Now I multiply it out, and I'm going to go ahead and get this business of 4, oops. So I'll get 4x squared, and then I'm going to go 2 times 2, 4, times 3, 12, x plus 3 squared, which is 9. And now I've used the the perfect square trinomial to expand that out. Okay. Now, here's the deal, is that doing this out, you would do the same thing, okay, for this guy. So just kind of setting it up here like that. That is not what I wanted to write. There we go. But if you have a negative sign in there, then this whole thing has to be captured. So the A is going to be this, and B is going to be a -3. So we do the exact same thing. So we would have this, 2x, and B equaling a -3. Okay. Notice that it was a +3 here because of the plus sign. If it's a negative, it needs to carry on down. So from here, we're going to plug it on in, and I'll write it all out, just so we're getting some good practice and visualization. And so, and likewise, every instance of A is going to turn into a 2x, and every instance of B is going to turn into a -3 this time. Okay, and so here we go. We got 2x squared plus 2 times 2x times a -3 plus -3 squared. Remember to always put this part in the parentheses here, otherwise you're not going to like what's going to happen. So it'll be wrong. So from here we go 4x squared, 2 times 2, 4 times 3, -12x. Okay, and then we got a -3 times a -3, that's going to be +9 right here. Okay. So a more complex example of this is going to be something that looks like this guy right here. Okay. And basically the reason being is that it has more variables in it. Okay. So let's see, using the pattern, on how this plays out. So if I have an A plus B here, and I know that A is going to be x squared, and B is going to go ahead and be, let's see, 4y cubed. Okay, so that basically is going to be dropped into the same pattern. Okay, where every A turns into an x squared, and every B turns into a 4y cubed. All right, so write this out. We get x squared plus 2 times x squared times 4y cubed plus 4y cubed raised to the second power. Okay. So simplifying this out, I will get an x to the 4th power, multiplying those two together. Let's see, 2 times 4 is 8, and then I have x to the 2nd, y to the 3rd. Okay. And then I'm going to be putting this in, so that's 4 times 4, that's 16, and then this multiplying in is going to go ahead and give us y to the 6. And so this is going to go ahead and be our final expansion using this business of the perfect square trinomials. So that's how you do that. And from this lesson, we're going to be moving on to something called Pascal's triangle, which is going to be basically an expansion of using these patterns. So that's coming up next, and I'll see you in that lesson.